So hello guys, in this video we are going to solve this problem. So in this problem it is given that we have a series whose terms are of this type: root of 1 divided by 1 plus root of 1 plus root of 2, root of 2 divided by 1 plus root of 2 plus root of 3, and this will go up to root of n divided by 1 plus root of n plus root of n plus 1. And in the problem it is given that this summation is equal to 10. Then we have to find out the value of n up to what terms we sum, so we get the value of 10. So we want to tell that in this problem. So let's see how we can do this. So I can form general term in this way, like root of r divided by 1 plus root r plus root r plus 1. So I can form general term in this way. So if you find the first term, then t of 1 will come like root of 1 divided by 1 plus root of 1 plus root of 2, which is similar in the problem. And if you find the second term, it will come like root of 2 divided by 1 plus root of 2 plus root of 3, and this will also be similar. So we can form the general term in this way. Now what we can do here, we can split the denominator in two parts, like one is 1 plus root r and one is root of r plus 1. So I can multiply by 1 plus root r minus root r plus 1 in the numerator and denominator both. So it will become like a plus b, a minus b, which is a square minus b square. So it will be 1 plus root of r whole square minus, here it will come like r plus 1, and in the numerator we have this thing. So you can open, it will come like 1 plus r plus 2 times root r minus of r plus 1. So this and this will cancel, and in the denominator we have 2 times root r, and in the numerator we have all these things. Now you see this root r and this root r cancel, and we only left with half and this thing. And now we want to find the sum of n terms. So we can do from r is equal to 1 to n, the tr, which is tr is the rth term. So we want to find the sum of n terms. We can write in this way, and this thing will come like this. So this one factor is independent of r, so we can take this outside. So this will look like this. So this thing will give us n. So it will come like n by 2. This whole thing will come like n by 2. So this thing will come like n by 2, and now we left with this thing. So r varying from 1 to n. So you can replace different value of r. So if you replace r by 1, then it will come like 1 minus root 2. But if you replace r by 2, it will come like root 2 minus root 3. The next term is root 3 minus root 4. And if you replace r by n, it will come like root of n minus root of n plus 1. So all this factor cancel, and only remaining thing is 1 and this last term. And the half factor is obviously there, because this half is also multiplied by these two things. So half factor is already there. So this is n by 2 and this half factor, and we have this 1 and this thing. So now in the problem it is given that this sum is equal to 10. So we want to find the value of n. So you can simplify this further, and you can write in this form, like n plus 1 minus root of n plus 1 divided by 2. And we equate this thing by 10. So we want to find the value of n. So this is an equation in n, so we can easily find out. So here you see, if I replace root of n plus 1 by x, then it will become like x square minus x is equal to 20. So this is a quadratic equation. So I can solve for x. It will come like minus b plus minus root of b square minus 4ac divided by 2. So it will come like 1 plus minus. This is root of 81. So which will come like 9. So 2 factor will come like minus 4 and 5. So minus 4 is not possible, because we have x is equal to root of n plus 1. So root value cannot be negative. So we equate this by 5, and after squaring both sides we get like n plus 1 is equal to 25. So after simplifying, you can get n is equal to 24. So if you do the sum of 24 terms of this series, then you can get the value of 10, and in this way we can solve this problem.